Dear students, good evening. Dr. Sheikh Mastanamma from Acharya Nagarjuna University. Today we are going to be discuss about a practical session on calibration of pH meter. As we know that pH meter is used to determine the acidity or alkalinity of the solution. pH is nothing but the concentration of hydrogen ion in a solution or hydroxyl ion in a solution. pH scale ranges from 0 to 14, as we know that. So in olden days, pH was measured using pH strips. Nowadays, all are using pH meters. This is the pH meter. Pico Plus, manufacture Lab India. This is another pH meter, Systronic. This is manufactured Systronic 802. This is another pH meter, Elico Li 120 by Elico. This is a digital pH meter, Lab India. The basic components of the pH meter is a electrode stand, the functional keys, this left side containing the functional keys numbering from 1 to 9 or alphabets A to Z, and CE is the clear entry button. Next, right side keys containing MEM clear, that is memory clear button, cal button, cal button using during calibration, mode button to set the mode or select the mode, reset button, enter button, GLP button, use it to write any sample ID. We are using GLP button. These are the functional keys. Now the electrode. What is the working principle of this pH meter? As we know that the pH meter is used to measure the pH of the solution. The pH electrode, it's containing pH probe. The probe containing two electrodes. One is indicator electrode, another one is reference electrode. The reference electrode was filled with saturated KCl. The indicator electrode is a sensor electrode. It containing the glass bulb. The glass bulb is a porous membrane. Inside the glass, a silver coated wire is present. In reference electrode also, another silver coated wire is present, silver chloride coated wire is present. What is the principle here? When we dipped this glass bulb into the solution, from the solution the hydrogen ions are entering through the glass bulb. The glass bulb already containing the metal salts. The metal salts are exchanged. Because of ion exchange, the electric flow generate. The electric flow was captured by the silver wire. the silver wire that generate the voltage. The generated voltage is compared with reference voltage. The voltage produces the electrical signals that produces the pH, that measures the pH of the solution. This is the working principle of the pH meter generally. Now we are going to be calibrate. Calibration means to know the accuracy of the instrument. We are calibrating the instrument using any reference material. For calibrating the pH meter, we are using pH buffer 4, pH buffer 7, pH buffer 9.2. In olden days, we are using pH strips for measuring the pH. So the pH strips like a small books. Okay, so different colors are present here. pH 1 is one color, pH 3 is another color, pH 5 like this, pH 7, 8, 10, 11 up to 14 different colors are there. So we place one drop on this paper, then the appear color was okay, compare with the above colors. This is the measurement. It is not accurate. Nowadays we are using pH meters. So the commercially available buffer capsules also available. pH 4 buffer capsule. So this is a pH 4 buffer capsules. Capsules are available. pH 7, pH 7, pH 9.2, pH 9.2 capsules are available. Okay, capsules. Okay, inside the cotton. Okay, one capsule is many capsules are present. The next take one capsule. Yeah, this is the size. This is the size. Yeah. So in the form of tablets, buffer tablets. Okay. So you have to take one tablet. Take one buffer capsule. It is readily available commercially by the Coalitions company. Take a clean and dry glass mortar pestle only. Okay, this is a glass mortar and pestle. Place one tablet inside the mortar and triturate well. To get up to fine powder, triturate well. After getting fine powder, the whole powder was transferred into a clean and dry 100 ml volumetric flask. A few ml of distilled water was added to make the solution. After shaking, the final volume was made up to the mark with 100 ml with the distilled water, that is double distilled water. Then the solution was transferred into 100 ml beaker to dip the electrodes. Now the instrument, switch on the instrument first. Yeah, the instrument sound, the beep sound was observed. Then we have to stabilize the instrument for 15 minutes. After 15 minutes, enter mode button. The program was came. pH, MV, temperature and calibration. Our experiment is calibration of pH meter. Then in calibration mode, R letter is present. R is equal to N is present. R is equal to N means no calibration. That is, this instrument was not previously calibrated. If it is present any other than n, that is any alphabet from A to Z, the instrument was already calibrated. If R is equal to n means the instrument was not calibrated previously. Then you enter cal button, CAL, cal button, enter. Then it displays standard solution or calibration, standard solution 1 or calibration 2. We have to apply key 1, press key 1 for then enter. Then it the display shows what type of standard buffer we have to use first. First we have to it is a ranging from 6 to 7.2 the display shows. So less than 7.2 the buffer 4 is present. Then we have to transfer the buffer from the volumetric flask to the beaker, 100 ml beaker. Then dip the electrode, the pH electrode carefully, because the pH bulb is porous, it is very delicate. The electrode, dip the electrode into the beaker and measure the pH. Here the working principle is the hydrogen ions was enter into the glass bulb and the metal ions from the glass bulb enter into the solution. The exchange of ions, that is metal ion from the glass bulb and the hydrogen ions from the solution, that causes the electric flow that captured by the silver wire inside the electrode, that generates the voltage that converts the electrical signals to we can read the pH value. Now enter 4.0. After entering the 4.0, the instrument was stabilized to 4.0. Then the value display. After 4 buffer, keep 7 buffer, enter. The same principle, exchange of ions causes electric flow, that causes generation of voltage, that causes electrical signals. The display shows 7 reading. After completion of 7 buffer, wash the electrode with double distilled water. Each and every time we have to wash the electrode. Keep buffer 4, enter. Here also the same principle, the same working principle. Exchange of ion causes electrical flow that generates the voltage that was converted to electrical signals. The pH was displayed. Now again remove the electrode from the buffer, wash the electrode with distilled water, enter calibration key, press 1 key for calibration S. Now keep the next buffer, pH 9.2, enter. the display source. This is the display. Yeah, the instrument was perfectly calibrated using 3 buffers, that is buffer 4, 7 and 9.2. These are the ideal buffers for any instrument, for any pH meter. Calibration was completed. Here go to program, again back. Now see the calibration here. Previously we observed R is equal to N, that is no calibration. Now the R is equal to I. Other than N, the instrument was calibrated. It indicates the calibration. The calibration was completed. Now so for checking the accuracy of the instrument, here we are taking the pH buffer 10 solution we prepared, and we transfer the pH 10 buffer into the beaker and we dip the electrode. Now we are measuring the the buffer 10 pH. What is the display? It shows 10. So the instrument is perfectly alright. It was perfectly calibrated. Now, the instrument was calibrated. Initially, the calibration was performed during installation qualification. After that, the pH meter is very sensitive. So that's why daily we have to calibrate when we are using for measuring the pH of any acid, base or any biological buffers. The next, this is used for measuring the pH of various buffers that we are using in pharmaceuticals. Next, maintenance, that is the maintenance of electrode is very important. Inside the electrode, the saturated KCl solution is present, and the bulb is very sensitive. It's a porous bulb. Always keep the bulb in saturated KCl solution when the instrument was rest. Is there any, we observed any salt formation or oily formation on the around the bulb, we have to wash generally with 0.1 molar hydrochloric acid for 30 minutes. The next, if protein contamination, we have to wash the bulb with 1% peptone using 0.1 molar HCl for 15 minutes. Is there any oil contamination? The bulb was washed first, rub with cotton, then wash with 0.1 molar sodium EDTA solution. So this is the calibration of pH meter. Thank you for watching. She is my lab technician, Rajita. See you again. Thank you.